understanding correct? And minimum optimum bandwidth speed used on IoT systems. So there is no, so IoT, you cannot say what is an optimum bandwidth because every system is different. We cannot give you we can only give you a ballpark number. But in terms of numbers, if we talk about, if IT is using, say, for example, 1 GB of traffic, okay, for example, then OT will, or industrial equipments will use 50 to 100 MB at the max. Okay, so with, and we will touch base on that as well. So with, within OT space, to be honest, there is not much, traffic in the environment. So even if you are using 100, MB link that is called fast Ethernet, that is also, should be covered in terms of, taking all your bandwidth load for that matter. Okay, it is not as high or not comparable even to the IT space. So that is one thing, right? And what problems are often encountered in the application of IoT, OT security, or IoT system security? I think what you might be asking is what kind of challenges that we have been facing, right? So challenges are, people are not willing to give information. It's typically the IT, OT siloed workforce, right? And whenever we have tried to, ask questions of, how we want to solve their problems, what breach has happened, so a lot of places where we have gone, right, to do a risk assessment. So when we do anything, we ask them, okay, tell me what are the devices that you have. How do you know as of now the devices are communicating? What are your current assets? Okay, and once they tell us, right, that is something very different from what we find when we deploy our Cybervision security tools. Okay, and that we will touch base upon. So don't worry about that. Yeah. So if you have any following questions, or I did not understand your question properly, if you can kindly rephrase, Dr. Mohammed, that would be great. Yeah, appreciate that. Appreciate your question. Yeah, thank you. I'll move on, and so now let's see what's the difference between IT and OT at a high level. The difference could be as follows, right? OT traffic is deterministic. Okay, so we know, as I was telling you, okay, it's 50 MB, 50 MB. It doesn't go beyond that. It's very deterministic. We know this device communicates to this device, and we know how much traffic it could be. Where IT traffic is not, you start downloading, songs and other stuff, softwares from the internet. It can go more than 1 GB as well, right? So in the OT network, the process is the most important thing. But in IT, we know the most important thing is data, right? In OT environment, in OT network, the throughput of a network is not important, as I told, right? As compared to IT, where achieving high throughput is very important in IT network. OT network patching seldom happens, but in IT, more or less that. But in IT, more or less, we have a definite, patching schedule, maybe monthly or quarterly, right? So there's a very nice article a former Ciscoite wrote, a very nice blog post called "IT is from Venus and OT is from Mars." You might have, that might actually, be a precursor to a story or a book that you might have heard of, right? So he just wanted to emphasize the difference between the two worlds, and it is correct. There are many differences, and here I just picked some of them. Like in IT, we have general skills and competencies available to support, while in OT, we have very specific engineering roles, right? In IT, computing power storage is expandable. So we just buy more and more servers, we expand the network or hard drive and whatever. But in OT, computing power and available memory and storage is often very constrained. And in field devices, so you and these are placed in remote locations, could be placed in remote locations as well. So just go there and upgrade the PLC, get more memory, get more compute, right? That however, that doesn't work that way, right, with OT environment. However, the trend was the new field devices, PLCs and HMIs, they are becoming more and more powerful and more capable. But there's a difference to keep in mind, and that's why our security systems in IT and OT have to be very different. Like, for example, in OT, in IT environment, right, we can do a ping or a TCP scan of our laptop without any fear or damage to a laptop, right? However, if you do a TCP port scan on a PLC, okay, which is 10 years old, you can by accidentally do a denial of service attack, okay, on the PC, on the PLC, and that might cause a reboot of the PLC, okay, because you just exhausted their resource by, because whenever you scan, sending TCP messages, it has to, respond back to those TCP with an acknowledgement, right? So the memory is so limited on these PLCs, you exhaust the PLC and it becomes a denial of service attack for them, and it reboots, right? Because it was out of memory power. So that is one of the concerns with OT environment as well. In IT, high throughput is very important, okay? But occasional delays are okay. With high throughput in IT, we are okay to have occasional delays, okay? Mail might go 2 minutes late, no problem, okay? In OT, real-time delay are not acceptable, okay? Say, for example, okay, let's let's take example of a robot, right? Robot hand. They are called Fanuc robots, okay? You are making a car, okay, and there is a delay. So instead of the steering where it needs to get fit, it gets fitted on the seat, because the conveyor belt where the car chassis and body is getting carried, it went off, and that there was a delay in the hands operation. Okay, so you can well imagine how much loss might happen. So delay is not no-go with, actually delay is no-go with OT environment and industrial environment. Delay with IT is still okay. Okay, so that is something that we need to keep in mind. And risk in IT is mostly about loss of business or confidentiality. And so while in OT, typically safety instrumented systems, risk can exceed losses to the business. So it can become a loss of life or damage to the environment or injury to a person, because we are not talking about computers, we are talking about heavy machinery potentially, right? As I told you earlier as well. So use of standard protocols in IT is quite standard now, right? Because initially it was different, but now it's all TCP, IP, and Ethernet, right? So many of these protocols have mature security features now. But in OT, these specific protocols that we talk about, that's rarely the case. We hardly see any encrypted form of protocols in the OT environment. Okay, there are many standard open protocols, but there are a lot many proprietary protocols used by specific vendors. Okay, and this is not something that we generally see. The trend is we do not see the trend of having a single protocol. It's still very dispersed environment, dispersed ecological system in the OT space. Okay, but now we do see that some of the industrial vendors, they're trying to add a layer of security on top of their protocols by doing authentication and by doing involving cryptographical code in their protocols, right, to secure it. Okay, and IT, then we go to IT, as we discussed, has a short life cycle, 3 to 5 years. You go buy a router, probably you will replace in next 5 years. But in OT, as stated many times, long life cycle is something. The idea is, if something is not broken, don't fix or upgrade it. Okay, let it run. And that approach was fine, but now with digital transformation, now with connecting things, hyper connectivity through industrial, Internet of Things and so on, we start connecting, different legacy equipments to our network, and doing that actually exposes the equipment to potential attackers, and that is where it becomes very important to change our mindset. of, if it is not broken, don't fix it. Because if it is kind of broken, right? If it's insecure, it's kind of broken, and you can just expose it to the internet because uh, of this insecurity, and somebody might come from the internet, some backdoor, and might create havoc in your industry environment, right? And cause a lot of harm. And lastly, support options. Okay, easily available in IT versus in OT. Support options are also provided by suppliers or integrators of these PLC boxes, right? So in this slide, we talk about confidentiality, integrity, and availability. When we talk about IT, these are the three things, three pillars that we consider. In IT, confidentiality is the highest priority, followed by integrity, and then followed by availability. While in OT, availability or uptime is the highest priority. You have to have your systems running no matter what. Okay, that's the highest priority, and then followed by integrity, and then followed by confidentiality. It doesn't mean that only availability is important, but but it is probably the highest importance. And let me give you a quick example, okay, to explain why we claim in IT. Let's look at an example of an email, so to speak, right? If someone can get access to your email for 2 hours, it is much worse, than if you don't have access to your email for 2 hours, right? So if you do not have access to your mailbox, it is annoying, I understand. But for 2 hours later on, everything is fine, okay? But if someone can access your mailbox for 2 hours, you know what will happen, right? And if that person has a bad intention, you lose your confidentiality. It can be disastrous, right? All your confidential data can be exposed and so on. Okay, I'll just come back to the question. In OT, it is the important way around if someone can read the data from a turbine, okay? In OT, so other way would be, if somebody is, reading data from my turbine, how many rotations per minute and stuff. Though there is a loss of confidentiality, it's probably not a big deal for me as an operator, right? Because for me as an operator, my system is running and I'm happy with that. Because what will happen is if there's a system stop, huge losses, right? So if someone stops my turbine for 2 hours and stops my safety systems or stops my drill or conveyor belt, then potentially I am losing, I could lose lives, I could lose millions and millions of dollars as well. So you get my point. So availability is extremely important in the OT space. Right, let me come back to the question. On the main source of threats, so do you think industry must be limited? Yeah, so it's a fair enough question. So internet is the main source, but that's not the only source, by the way. So we cannot stop, connectivity from happening from the internet. So internet is not direct internet. Internet is actually your enterprise site. Okay, so you have a office site also, right? When we talk about the industries that or the plants that are there is an office site as well, where all the business, all the CIOs, CEOs, and top management sits, right? So that office is your internet in this case, because that's your enterprise network. And as I told you, the impetus is to get data. The impetus is to do well in business, to grow more. So if you want to grow more, do well in business, you have to have connectivity to know what's happening at the ground level. So the impetus is to have connectivity more. That is more important for customers now. So they want to move to digitization. They want to take a call to see what's happening on a day-to-day basis. They want to control what's getting produced, how are they getting produced, and how much are things getting produced, right? So that is one of the things that that drives connectivity between the IT and the OT space, and that cannot be stopped because it's a world of digitization. You want to do that. You want to control your fridge from your phone at your office. You want to control your car's AC from your office or your home. So those comfort, those luxuries are there, and that will drive connectivity, that will drive IoT forward. But there is a there is security that has to be built on top of it. That is what has to happen. Improvement means higher cost but much secure. What's the cost comparison between IT and OT space? There cannot be a direct cost comparison between IT and OT, because IT has its own set of devices, OT has its own set of devices, and I told you with OT space, it's all different ecosystems and different, I believe you're talking about cost in terms of money, not cost in terms of potential loss of business or something like that. But in terms of money, it's very difficult to put a number. We can always put a ballpark figure, but with OT, the cost of products and services are a bit high, because it's simple, right? We have very limited players in OT environment, but with IT, we have so many different companies. You will not be able to count it on your fingers. There are so many billion-dollar companies, but in OT space, top 7, top 10, there are very big organizations who are billion-dollar organizations like Schneider, Siemens, Rockwell, Yokogawa, Hitachi, so 5, 6 big players, right? So that is where there cannot be cost comparison, but in OT space the cost is higher because there are less players and it's proprietary based, right? Yeah, we can, but the only problem with those are, we cannot actually put too many dynamic things with OT, right? I told you, like with traditional networks, legacy stuff, it becomes very difficult, right? So that's why it's a bit of a problem to use these modern techniques. But we will look at it, okay, in a passive way. This is where Cybervision comes into the picture, and we will discuss that. Okay, don't worry about that. Good. So 38 we are in. Okay, so we'll move to the next slide. Now we will see what are some of the challenges that our customers have been facing in the industrial environment, right? As the equipment is still legacy in most of the industrial environment, these industrial systems are exposed to new threats. Okay? As proper security measures are not maintained, there have been a lot of attacks in the industrial control systems in the recent past, right? We'll discuss those in the upcoming slides. And there's a lack of or no visibility towards the OT assets at present. In few places, still the traditional method of pen and paper, okay, to keep a note of the inventory are getting used, or in an Excel, okay. As discussed earlier, there isn't any patching or maintenance system timelines maintained in the OT environment, okay. The approach is always on in the OT, okay. So they do not want to, put a patch, power cycle the device and install the patch. That's not their priority. Their priority is to run and make more and more production. That's the idea, right? So next, we talk about customers have some objectives. The objectives are to reduce the risks. That is the first thing. When we go to the industrial environment, they do a safety induction, okay. They will do so whenever you go visit a plant, they will start doing a safety induction, okay. They will make you watch. Sometimes they might make you watch 2 days of video and then you have to pass an exam, or they might want to make you watch a 2-hour video and then do a short training, right? So they explain the procedure in that, right? They explain the procedure, where you need to evacuate in case of a fire, or what is the personal protective equipment that you have to wear and that you must have. And so there's a big emphasis on the safety, and that whole idea is about reducing risk in terms of health and safety, also in terms of business risk. So then they have employee productivity, and it's their other objective as well, right? Of course, they are trying to make sure that their employees are productive as possible. So then there also comes asset utilization over and overall equipment efficiency also as one of the goals that they have. Then they have, compliance and regulatory goals that we discussed earlier as well. And then they want innovation. They want to differentiate. So if I have 5 car manufacturers, they want to innovate. They want to uh, differentiate themselves against the competition. How are they going to do that, right? So some of these challenges that they are facing, while they have these objectives, that is IT versus OT and aging infrastructure, aging workforce, OT workforce. So again, OT workforce is, by the way, aging. Not a lot of people are going into, you guys, a lot of you guys are very young, so nobody plans, okay, I will be a OT engineer, I will be a system integrator. Very few people have their aspirations now. So the workforce is generally who are working in this OT space are generally the aging people, okay? And the people who are there, they have been operating for many years, so they are not open to that digitization change. That also needs the mindset change, right? So then the other important thing for us is the security concerns. Security is a major showstopper for industrial IoT, as we have discussed. But again, it is a major showstopper, but we'll still need to connect because we have to connect because that's convenient for us. Data accessibility and control system, and many of their assets are working in silos. So when we are trying to make sure that the data accessibility is everywhere, they are connecting things. But once again, when you start connecting things, you again have a security concern, right? So when again the same proverb, like chicken came first or the egg came first, right? So when you connect, you bring security concerns. Okay, with security concerns, not many things can happen, but you still connect. And then the lack of standardization, this is something then that we faced in IT environment many moons ago, but now mostly, as I told you, it's all standardized, use TCP, IP, Ethernet, but in only OT environment, no standardization. Different vendors, different protocols, own protocols. If you have to run my equipment, you have to run my protocol. That's the challenge that we have been facing in the OT space. Okay. Now, skill shortage, we just touched upon those. Don't get a lot of people with good understanding of industrial environment and OT process, but at the same time, be aware of good cybersecurity knowledge. So when securing industrial networking, this is one of the big challenges, right? Another challenge, which is another challenge which has gone hand in hand with this is the growing amount of threats. Okay, so attackers are actually getting more and more capable because there are, as I told you, there are tools readily available on the internet. You just install Kali Linux, right? And you download it. You don't need to download anything. There are inbuilt tools that can perform hacks in this old legacy infrastructure of industrial environment, right? So compliance is also one of the challenges because we already spoke about it. Governments are, different regulators are making, different terms of compliance. So the customer needs to comply as a manufacturing unit, as an industry, as a, as a utility space like TNB, we have to go with what government says. It's a mandate, right? So that's the main thing. And agility, so we already discussed, right? So touch base those. Sorry. Yeah. So we did touch base on that, right? What are the factors we concern designing secure network space for industry? So firstly, we need to have segmentation. And firstly, it's visibility, right? We have to know what's there. Only what's there, we can start segmenting, okay? Once we know that, we start segmenting, then we have to first visibility, then segmentation. Then what we need to do is we need to have policies, proper policies in place, and then those policies have to be implemented. Okay, so these are the 4 factors that when we, design or try to design any form of industrial network, because industrial network is not greenfield. You can understand that. Most of these companies are there for a long, long time. So it's all brownfield. It's already there. So visibility, segmentation, proper policing, and then proper measurement of control is four things that we generally will try to do in this industrial environment. Yeah. Hope that answers. Yeah. Yeah. In a nutshell, yes, that is correct. Yeah. Thank you. Thank you. So, yeah, so these are the, you know, we were discussing of what happened, right? Yeah, real life examples of OT attacks, right? So if you Google OT cybersecurity attacks, you're sure to find a lot of attacks that have happened in the last 10 years, right? So here we generally will discuss about two attacks that have happened. One is Stuxnet and the other one is Black Energy, right? So Stuxnet happened in an Iranian nuclear power plant called Natanz, right? And it happened in mid-June 2010, so 11 years back. So you can well imagine, right? And actually, it was discovered by accident because it had a flaw in its program, in the malware itself, by the way. So it spread beyond its initial target, and but still within the plant, by the way. So, but then one of the operators in the plant recognized something bad has happened and something was going on. So he went to an ICS security mailing list and asked, "Hey guys, I'm seeing this values, which is not expected." And then the attackers, the actual attackers, you know how powerful they are. The actual attackers saw that email, okay, saw that post, okay, and immediately saw the question. They knew that their malware was found. So what they did, they orchestrated a distributed denial of service attack to these email servers or these, blog post servers, and two of these leading mailing lists, uh, these were actually down for many days because they did this denial of service attack. So the guy who posted the question never got to see an answer back because they have taken the server out. The attackers were that powerful, okay, in terms of their contacts, in terms of their resources, okay. So obviously that increased the time for them to get a resolution, right? So, and by the way, this was all state sponsored attack, right? State sponsored means there was countries behind that attack. Okay, you can read more on the internet. I will. Okay, that would be better, I guess. But this was done by two countries, which orchestrated this attack on Iranian power plant. Okay, so you can understand the amount of resource and power that one might have, right, to orchestrate these kind of attacks. The next one was, Black Energy. It was very famous and first attack on power grids in Ukraine. It was first discovered, in 2007, and then it evolved in a new attack in 2010 as a Black Energy 2. And in 2014, there was another evolution to this attack that was Black Energy 3. And it was typically, attacking the power grid and the power management system, right? The outcome of this attack, was 30 substations had to be switched off, around 230,000 people were, without any power for 1 to 6 hours. Okay, technical details are there. I will not bore you with that, but yeah, you can read more on that. It's quite interesting how these attacks have happened, right? Now, the question that a lot of you guys have been asking, how do we protect it? There's so much problem, right? How can we control and protect this? And this is where, Cybervision has come. So just to give you a brief understanding of what Cybervision has been doing is, Cisco, being a leader in IT security for many years or even decade, we have a wide range of different security solutions. Okay, and integration. So our security portfolio is very strong. But with Cisco, we made the decision to, extend our offer into the OT space. Okay, because we are doing OT industrial, IoT devices portfolios we already had, like switches, routers. So we wanted to expand our portfolio into the industrial space. So in June 2019, Cisco announced the intent to acquire a company called Cybervision, which was formerly known as Centrio, which was based out of Lyon in France. Okay, and we rebranded Centrio with a new name of Cisco Cybervision. Okay, so majorly we classify Cybervision to do three functionalities. One is to provide the visibility part, then the operational insight, and then lastly, this is threat detection, right? And we'll discuss all these points, by the way, in our upcoming slides. So, no worries. So the journey to secure industrial environment is kind of four-step process. Okay. So the asset visibility is the foundation of any security, because if you don't know what you need to protect, you will not know what you have to protect, right? And Cybervision is solving that problem. The next step is that the journey of network segmentation. You have separate OT, IT, industrial, DMZ that we discussed. Okay, so segmenting network IT with OT with a IDMZ in between, sandwich in between, that is something that is very important. And doing this segmentation, this is kind of a proactive thing in the ICS customer that they can do, right? And the next thing is to get the capability to do real-time threat detection. So customers need to, quickly as possible to, detect and understand, okay, a threat has happened. Okay. So that is, threat detection is very important. And then finally, the last piece of the puzzle is a reactive kind of a services provided by the SOC. Okay, SOC is nothing but the Security Operations Center. Okay, whether it's an integrated IT, OT single SOC, or if there is a separate IT SOC or OT SOC. SOC is nothing but like, it's really like a NOC, right? Network Operations Center, Security Operations Center, right? So it depends on the nature of the customer, but generally speaking, there needs to be some kind of reactive service to counteract the threat that has happened. Okay, that is very important. So about Cybervision, right? So it's kind of a two-tier monitoring architecture. So what it does, so what we mean by two-tier is there is a centralized component called Cybervision. Okay, it has centralized analytics and data visualization. Basically, you as the user log into Cybervision, and then there you can go to the dashboard. You can do all forms of reporting. Whether you like to see Cybervision, okay, this is mostly the home page is the place of your interest mostly, right? And also with Cybervision Center is used for integration between different Cisco products. So with some third-party solution there, that's the role of the center. Okay, so what you can do is you can integrate Cybervision with other portfolios as well. Okay, for example, you can have ICE integrated with Cybervision. You can have Stealth Watch. These are nothing but Cisco security products, which we will not delve in because that's a different conversation. Okay, so those things can be done. And then you have partner integration, like we can see on the right hand side, right? So SIEM is nothing but the security and event management center, right? So you can get those logs into SIEM, and SIEM will do kind of run analytics on top of it, and get you meaningful data, right? So those are the things that can be done. So yeah, this question. Let me just check. Okay. So how does DMZ differ? So DMZ and IDMZ are same. Okay, it's just DMZ is why they have been given a different name is because you are DMZ is generally used in the enterprise segment, and IDMZ for IT and OT segmentation. So the idea is quite clear, right? You are segregating with firewall on the perimeter level, at least on your enterprise side. What happens? You have three zones, right? External, your internal LAN zone, and your DMZ zone, right? There your servers are kept. Here, everything, here with IDMZ, everything is kept separate or segregated. Okay. So that is, what you can do is you can totally segregate all your, network or your components in in IDMZ in a manner where, it's totally segregated with your enterprise. So the idea is, segregating that enterprise. So idea is that you have whole of your OT system segregated from your enterprise system, but the functionality is the same. The role and the placement is different. There's no other difference actually. I hope that answers. So yeah, so let's move on to the next slide. So digging deeper into this, we have what comes is Cybervision comes in two shapes. One is a hardware appliance which you can run on a any kind of a blade server, okay, with ESXi running on top of it, and then there is a hardware device as well, okay, where you can deploy it as an appliance, okay. And there are two different main types of sensors. So you have two different types of sensors generally available. Okay, one is the industrial, called IC3000. Okay, this is nothing but an industrial PC, okay, compute where we can run sensors, and we will discuss what are sensors. Okay, and you can install Cybervision sensor on, as I told you, on the IC3K as an application. So IC3K is nothing but a server, as I told you, and it runs a form of a Docker container. So you can run your sensor application there on top of Docker container, right? And then so there is also in the industrial environment, we have these other things as well, right? So for example, the other devices, IE3400, IE3400, IR, Catalyst 9000, these are, so IE3000, IE, all these IEs that you are seeing, these are nothing but industrial Ethernet switches. Okay, IR is industrial router. So IR, what is IR? What is the difference between IE and IR? Whenever we start with I in Cisco, it is nothing but industrial grade. Okay, so you have IP67 certified, and you have dust protection, you have waterproofing, you have high temperature and low temperature protection. So these are the equipments which we can run our sensor application in. And why we need to run on these boxes? Because these boxes will be placed in plant environment with harsh conditions, right? So we need these IE devices actually to run these sensors on, right? So deep packet inspection running on IOX, as I told you, and these IOX that is there, IOX is nothing but a container-based services which again talk northbound to the Cybervision center, right? So if we take a look at the ideal picture on how we imagine that one industrial network should look, right? They should ideally have the whole ICS network built using Cisco's IE switches. Every switch should be able to run the sensor and then get full visibility across the whole network. So you don't need to pull additional cables anywhere. You don't need to have additional hardware for the sensors as well. And at the same time, you'll get all the benefits of having Cybervision security solution in the OT environment. So the main thing is easy deployment, total low cost of ownership, and additional hardware sensors are not required. So there's no impact in the performance as well, right? Let me quickly skip through this because I think we are. How much time do we have? Do we have half an hour more?
The Our first, this one, it will end on 12:30, but maybe
Okay.
you can have another maybe 10 minutes.
Okay, fine then. Yeah, then we will quickly skim through this actually. Okay. Uh, what this is showing is, um, so now another approach is, what we have seen with our competitors is they have so the sensors are nothing but tapping points in the network. Okay, so the sensors are just tapping the network, getting all the information and putting it onto the Cybervision center for us to see. Now, why this information is needed? We have to understand that, right? As I told you, we cannot do scanning on the network, right? We cannot do, okay, please scan this and get the information and try to do things that way. That works in IT. With OT legacy equipments, we do a scan, we crash the device, right? So what we do is we connect these PLCs or these HMIs, okay, into the Cisco's I switches, okay. I switches are nothing but sensors. So they sense what all is going on. So they are doing a packet capture, okay, of the communication between these sensors, the HMIs, these PLCs and everything, right? And they will only send out a metadata northbound because it's a tied architecture, right? Northbound, they are going to send it up to the Cybervision center. Cybervision center will show us the analytics part, okay, of how the communication flow is happening. Now, how does that help? We have to understand that, right? We told that, hey, we don't have visibility, we don't know what's there. But if we do a packet capture end to end, we know what's talking to what and who is talking to who and with what protocol, with what port number by these tapping points, right? Then we know everything of the network. We have all the information. We just need to visualize that, and that's what Cybervision does. And where Cisco takes advantage of it is there are other competitors doing this solution, okay, where they are also giving that same functionality mostly, but they come with an additional cost. They are putting their sensors, which is nothing but a hardware box, and tapping to the switch, okay. Switch, industrial switch, could be Siemens switch, could be Cisco switch, could be any switch. But with Cisco, the sensor is inbuilt in the switch. So if you replace your switch with Cisco switch, you just get that functionality built in, right? You don't require to purchase new additional hardware for the sensor. Okay, that is what we are bringing into the table for the customers, right? The Cisco. And with additional hardwares, it becomes expensive. You need to run span protocol. Okay, span is nothing but you are duplicating all your traffic and sending it to the sensor. Okay, so that is extra overhead as well for the entire OT network, because whenever you're duplicating packets and sending to the sensor, that is more process CPU on the sensor itself and plus on the switch. So there is more traffic than it needs to be, right? So what does the traffic bring in? It could bring in jitter. So what our other competitors are doing is they are bringing in a separate span device, which brings in a lot of jitter, a lot of problems in terms of latency. There could be another high traffic volume that can be seen, right? So that those are things that can be observed. But what is Cybervision, what these sensor equipments are doing, they are only sending, they are not having any additional spanning or something that is getting done. They're just taking that metadata. Okay, metadata is just very small pastoral and sample data from that entire data set, and little bit, only 5%, 3 to 5% is getting sent to the Cybervision center to do the analytics part, right?